All right, good afternoon, everyone. So yeah, I'm Jason Patton. I'm here with the CHTC here at UW-Madison, and we're going to talk some GPUs. And we'll start first off with the basics for admins and users alike. If you've got this nice brand new server with a bunch of GPUs in it, how do you actually get HTCondor to use these? I think we've made this pretty simple over time. And I just hit the wrong button. Hey, there it is. We have this nice meta knob that's use feature GPUs, and more or less you stick that in your config and you're good to go. Under the hood, this runs something called Condor GPU Discovery, and it sticks all the GPUs it sees into a bucket of GPU resources that you can assign out as you like. So again, if you're already using partitionable slots, this is pretty easy. All you do is you add the use feature GPUs and you're good to go. If you're doing static slots, it gets a little bit more complicated. So you might need to read through the Condor manual or whatever you did when you first try to figure things out and review that to see how you might want to dish out the GPUs that you have on your machine. This is just a quick example where, if you wanted to make 4 equal size slots, if you had 4 GPUs in a machine, that's one way you could do it. For the users, how do you actually request GPUs? And I think, again, we've made this pretty simple. Just like any other resource, you would add a request for it. So request GPUs equals 1 if you want 1, equals 2 if you want 2, and so on. Just be aware that you still need to list all the other resource requests that your job needs, be that memory, not GPU memory, but just regular memory, disk, and so on. And note that just request GPUs alone will not tell you anything about what kind of GPU you're going to get. You might go get a nice A100, you might get a RTX 4090, or you might get the GTX 1030 that I have running on my laptop that I hooked up to the pool. So here's a quick example of what this looks like. Again, along with all your other requests, you stick in your request GPUs equals 1, and Condor will go out and get your job a GPU. One thing I wanted to note, because a lot of our GPU users do tend to use containers, is that you might also want to be wary of your request disk might need to make sure that you're taking care of your container size, and that depending on what kind of container technology you're using or whatever, just as a safe bet, make sure you include your image size in your request disk. So as I mentioned, just request GPUs on its own is not going to tell you what kind of GPU your job is going to get. If your job has some kind of specific requirements, for example, if I saw that, PyTorch, that needs CUDA capability at least 8. We have, starting in HTCondor 10, this command, submit file syntax, submit file command called required GPUs. And generally speaking, the most common targets that you're going to want to use this for are capability and memory. And again, only if you need to use it. If you can work with any GPU, that's going to be the best thing to do, because then you'll get the most GPUs. You'll have the most GPUs available for your job. And so this is what this looks like. So again, we start off with requesting a GPU, but now we have this required GPU syntax. It's going to look very similar to requirements, if you're familiar with that. Where let's say I find out that PyTorch needs CUDA capability of at least 8. I can stick that in here. And I know that my job is going to use at least 16 gigs of GPU memory. I can stick that in here. So my job gets going. It starts running on the execution point. How does my executable actually know which GPU to use? Oftentimes you might be landing on a machine that has 2, 4, 8 GPUs. What HTCondor does is it sets this environment variable, CUDA visible devices, to the GPU UUID. In the default case, at least, it'll be some kind of identifier for the GPU. And very importantly, your software must know how to use this variable. If it doesn't, then it's kind of questionable what GPU you'll actually end up running on. So just to do a little quick interactive job example, what this looks like, if I submit an interactive job that's requesting a GPU, and then after 20 minutes or whatever, it finally ends up running. and look at CUDA visible devices. In this case, I have this GPU assigned to my job with this UUID. And so if I go through and actually list out what GPUs are on this machine, you can see that this points to this particular GPU on this machine. It's not GPU 0, which is oftentimes if you don't specify in your software what GPU to use, that's where your job will end up. So again, we don't want to sit here and have all our jobs oversubscribed GPU 0. But in this case, it's running on GPU 1 because this UUID matches the UUID here. All right, so my job ran. What did it actually do? Since for a long time now, I think going back to HTCondor 885, if I read the release notes correctly, we include GPU monitoring with the use feature GPUs meta knob. And this provides us two measurements provides you, whether you're a user or an admin, with two measurements of GPU usage. The first one is average usage. This is like the amount of time that the GPU was being used during your job, or the fraction of time. So suppose that your job ran for 10 minutes. It was using any small or large amount of the GPU for 8 of those minutes. Your average usage would be 0.8 or 80%. And then the other one that we provide is peak memory usage. So you want to make sure that you get a GPU that's going to be able to cover the peak memory usage of your job. And this usage is recorded in the user job log, in the job ads, and in slot ads. So if we take a look at a job, for example, if I tail a job log file, you can see here, in addition to the usual suspects here, we have GPU's average, which is the average usage that we talked about before. And it even gives you which GPU was allocated to the job. And then here it says GPU's memory, but be aware again that this is the peak usage. Similarly, we can go look at the job ads. So if I look at the job history for this particular job and I look at these particular attributes, GPU average usage and GPU's memory usage, these are the attributes in the job that correspond to these measurements, we get out basically the same numbers, just not cut off. And then if you want to know how many GPUs you have available in your pool, you can always use Condor status to look at that. To sort of try to put what I've written here into words. Oh, these don't line up right on this machine. Well, dash compact is shorthand for show only machines, the partitionable slots on machines, and most pools, or at least most same pools that you come across, that's going to mean just sum everything up into a single machine add. Total GPUs greater than 0. Doing dash const or dash constraint, total GPUs greater than 0 is going to mean show me only machines that have some GPUs. And then dash AF for the auto format here. If I passed machine and total GPUs, that's going to say show me the host name and the number of GPUs each host has. And so if I run that in CHTC, or at least my mockup of CHTC here, you can see which machines have how many GPUs. This doesn't show how many GPUs are free at any moment. If you want to know that, you can replace total GPUs with just GPUs. But hopefully your pool is using them, and so you'll probably see usually that'll be 0 in your pool. All right, so those are sort of all the basics out of the way. I'm going to go through a couple of advanced things here. This is going to be a little bit more towards admins. So if you're a user, you can take your after lunch mind break here, but I'll try to help you perk up by calling you out if I've got anything for you. And then before we get into things too deeply here, I wanted to point out that TJ gave a really nice talk last year on pretty much everything GPUs, especially anything that's been new in HTCondor 9 and is now the default in HTCondor 10. If you pull up the PDF of this talk, I will have timestamped links to the YouTube version of his talk on some of these slides. So the first topic I want to talk about is heterogeneous GPU devices. So maybe we stuck that A100 and the RTX 4090 in the same server for whatever reason. This is handled properly now in HTCondor 10 using nested class adds. This is the default behavior. And what this looks like is in each of your machine slot adds, you will have a list of available GPUs and a nested class add per GPU that actually describes all the properties of each of those GPUs. So for an example here, let's say I have a machine that has 2 different GPUs, and take a look at its slot adds. If I scroll down and get to the available GPUs, you'll see 2 GPUs listed here, each with its unique UUID. And as I'm scrolling through all the attributes, I'll see that first GPU here and all of its attributes in this nested class add. Again, going back to our users before, most importantly, what they care about probably are the global memory, which is provided in megabytes, and the capability. And then again, I'll find that second GPU as well and the list of attributes. And again, it might have some different amount of memory, some different capability, and that's what was really going to matter for our users. So talking about our users again, so if you were already starting your nap, now's the time to pay attention again.
Jason,
yes.
Can you go back one slide? Just to avoid confusing, the coloring is swapped on these two. You need to look at the numbers, not the colors.
Oh, good catch. So yeah, talking about users again. So this is where this capability and this global memory MB or megabytes came from. I just wanted to point this out, that there are other attributes all listed along here that you could potentially match on if you needed to. But again, for most users, it's still going to be capability and global memory that you care about. But if you're really really power user, you want to dig into this a lot more. Again, TJ made a nice talk about this, and he dug into sort of all the gory details here. I just wanted to quickly talk about splitting GPUs into MIGS devices. If you don't know what this means, then it probably doesn't apply to you. But if you have like nice A100 devices that you're thinking about splitting up, just wanted to be aware of a couple of caveats here. In particular, that when you do this, you'll only see the full ugly UUIDs for these devices. This is an NVIDIA imposed limitation, as well as that you can only use 1 MIG device per job. I guess it's really per process, but the details get hairy there, and it just becomes a mess if you try to use two MIGs per job. One other thing that we've observed in CHTC is that some GPUs can be notoriously flaky. They'll just stop working for who knows what reasons. We've added the ability to set GPUs offline in the execution point config without having to kill running jobs. This is the config knob here, offline machine resource GPUs. And to show what that looks like, again, if I have this machine where I have these 2 GPUs available, let's say one of them is starting to become a problematic, so I stick it into the config as the offline machine resource GPU, and then run Condor reconfig. If I look at the machine again, you'll see that it's no longer listed in the available GPUs, and so that GPU will no longer be matched to jobs. And then I can talk about prioritizing GPUs on GPU jobs on execution points. So you have these great GPUs on a machine, but you don't have, you still have more CPU cores than you have GPU cores, and maybe not everyone's using up all those CPUs. But you want to make sure that GPU jobs are landing there first. What can I do? First, a really easy way to do this is to split up your machine into 2 partitionable slots. The first one would contain all of your GPUs, and you would modify the start expression so that you will only accept jobs that request GPUs. And then you have a second slot that's going to catch all the other jobs that could potentially run there. Another option is to set up backfill slots. Old way of doing this before Condor 11, we'll see in Todd's talk, is to use something called Bologna batch, which has all sorts of caveats and things and interesting issues that we've run into HTC that I don't even want to talk about it today. But the new improved way is to use what would be first-class backflow partitionable slots. The idea here is that GPUs may or may not need to preempt backfill jobs. It all depends on what kind of resources it's using. Maybe we know that in general in our pool, our GPUs jobs don't really actually use the CPU that they're allotted that much. So maybe we actually want to, where am I at here? Oh, wrong way. Yeah, here we are. So maybe we actually do want to allow oversubscribing on CPUs. So it's all, you can come up with all sorts of expressions here depending on what kind of resource contention there is. And so again, see Todd's talk tomorrow about what's new in HTCondor. Another thing that we've observed is that GPUs do tend to handle oversubscription pretty well if as long as they're not running out of memory. One way we can provide this option to our users is to assign the GPU multiple times to different slots. The option here is to add a dash divide option to the GPU discovery extra knob in the execution point config. And that will just duplicate the same detected GPUs, UUIDs multiple times before actually assigning those GPUs to slots. The big caveats here are that there's no Condor limit on the amount of GPU memory each job can use. So if you have two users using the same GPU and they do both want to try to use all the memory on that GPU, they're going to have a bad time. And of course, if you have two jobs using the same GPU at the same time, there's no security between the two different executables. And just to show an example of what this looks like, you take your GPU discovery extra and just tack on dash divide, whatever number you want, 2 here, for example, to allow a GPU to be listed twice. A new option that's coming soon is to use job sets. Again, I'm pointing out Todd might be able to talk about this tomorrow. But the main idea here is that at least a single user should be able to know how to best fill up a GPU that it has a lease on with multiple jobs. So with that, I thank you all for your attention, and I would be happy to answer questions.